Welcome to day 11 of our video solutions for Barvember. Question 1. As we start all questions, have a quick read of the question and think, how many bars am I going to need here? Well, it's about mugs and cups, so I think I'm going to need 2 bars, one for mugs, one for cups. So we'll see how we go. So our mug costs £10 and we've written the 10 in the bar. Now look for clues in the language as to how big our bars need to be. There's a big clue in our second line here that 2 mugs cost the same as 5 cups. Okay, so let's see how that pans out. So there are 2 mugs and they're the same size, 2 equal parts of 10. And here are our 5 cups. And you'll see that the red bar and the yellow bar there are the same lengths because the cost is the same as. Okay. Now, when we have equal parts like this, it's a big clue to us that we've either got a division problem or a multiplication problem or possibly both. So let's see how we go here. Now, our final part of our model here was to put our question mark in, which is just to indicate how much 1 cup costs. So everything that's in our worded question is now in our picture model, and let's see how the maths pans out. Okay, now don't try to do it all in one go. Let's just start from where we have most information, and the only information we have is the £10 for each mug. So what can we do? Well, we can add those up, so we know that the total is £20. Now, what else do we know? We know that the cups are the same as the 2 mugs, so that must be 20 as well. And as I suggested, with equal parts, we can now do a division calculation. And oh look, we've solved our problem. Question 2. Same starting point, how many bars? Well, a bit of a throwback here to Mel and Kim. And so I think we're going to have 2 bars, one for Mel, one for Kim. Kim has 4 times as much money as Mel. Equal parts. Big clue that we're going to be doing some multiplication or division. Always look out for equal parts when we're bar modelling. Kim has 48p. Now, we've used our curly bracket here just to show that we're including the 4 parts of Kim, and that's what makes up the 48p. We use your curly bracket again here. How much money do they have all together? So that's suggesting some sort of total altogether. So we've got our question mark and our curly bracket. Now, how do we go about solving this? Look, let's not try and leap from the 48p to the question mark. Let's work gradually, solving the jigsaw puzzle and see how we go. So we're going to start with where we've got the most information, which is the 48p. What can we do? Now we've got equal parts. So hello, here's the division calculation. Carrying on with our jigsaw puzzle, what do we now know? Well, hang on, these are equal parts. So that final part for Mel is also 12. Equal parts, 5 equal parts, and we can do our multiplication. Done. Question 3. Now, just a word of real warning with this question. And this question, I'm going to do 2 different ways because there's an awful lot in this question that's important about bar modelling. But the warning I've put at the top here is that if you look at line 3 and line 4, we've got what she has left, and then she has something left. Now, these bits that are left refer to two different amounts. So this is why we need to read the story, read the question as a story, because so often it's happening chronologically, it's happening in sequence. Okay, so has left here refers to two different amounts, and you'll see that in due course. So as usual, we're going to start with how many bars. Now, Linda has some money, and then she does various things with it. So this would normally be that we have one bar, and I'll do it with one bar to start with, but then you'll see that actually the question is really a bit more complicated than that, and we're probably better off using two bars. But let's see it with one first, okay? So she spends a third of her money on a book, okay? 3 equal parts. She spends a sixth of what she has left on a game. So what she has left are the other 2/3, and that's what we've divided into 6 parts. Okay. Now that means that everything here divides up equally. Now this is a little bit cheeky here, because if that wasn't a sixth, if it was a different fraction, this could play out very differently, which is why I've done the question a different way in a minute. But she spent a sixth of what she had left on a game, and she has £45 left. So this is now a different amount that's left, but we know that that's £45. Okay, so that amount that's left is £45. It represents 5 of these parts, so each of those is 9. In fact, everything here is 9, and we can see that the book cost £27. 3 lots of 9. But as I say, I think that's a little bit of a fiddle, so I'm now going to do this separate, a different way. And I'm going to do it with 2 bars. I'm going to do the third of the money that she spent on a book, and I'm going to now have what's left, which is the remaining 2/3. Okay, so let's label this up nice and neatly now. So this is a third that's spent on a book. The has left, what she has left is these 2/3, and all of this together is Lydia has some money, Lydia's money. Okay, so we can now deal with this second bullet. Okay, so, and this is where we have this sort of before and after representation if we want to deal with the same amount of money twice. Okay, so this is the bit that she has left in, and it's a sixth of this amount here, these 2/3 that she spends on the game. Now, the advantage of me drawing it this way is that it wouldn't matter whether this is a sixth, whether it's 2/7, whether it's 3/11, in that in the previous example, it all worked because we could divide everything neatly up into sixths, but we might not be able to. Okay, so this is absolutely fine how we've done it here, and we're going to see that we actually have to put in some extra steps in our calculation. And I can now show the £45 that she has left in the third bullet after spending the 1/6 on the game. Okay, so let's now see how the maths goes here. And remember, we're solving a jigsaw puzzle here, so we're going to start where we have the information. And the only information we have, the only numbers we have, are the £45. So what could we do with that £45? Well, we see that it represents 5 parts. So our first step here is to identify those parts. Okay. Now, again, working along from our jigsaw, we know that the amount we spent on a game, this is a part which is equal to these that we've just worked out. So we know that that's 9 as well. Working along, okay, I know that all of these are 9 equal parts, division, multiplication. I can now do the multiplication to find out that these 2 parts equal 54. So again, equal parts, I know the total. What can I work out? I can work out each of those. And in fact, we didn't have 2 equal parts. Remember, this third from the very beginning of the story is equal to these 2 parts here. So there we have it, and we've answered our question. Okay. So no apologies for doing that question twice. It's a difficult question, but I think the second representation is more useful for the first representation because the 1/6 could have been any fraction and this model would have worked out here. Question 4. Now, I'm not a big fan of this question either, but we'll work through it and you'll see why I'm not a big fan of it. Okay. So how many bars do I need? Well, I've got some purple and I've got some yellow flowers. So I imagine I've got 2 bars, purple and yellow. And we've got a ratio, purple 6 and yellow 7. And with ratio questions, all of these parts must be equal. So I've got 6 equal parts and the 7 parts for yellow are the same size as the purple parts. So that's line 1 of our question done. Now, twice as many yellow flowers are removed as purple ones. Well, that means I could take away 2 yellow ones and 1 purple one. And if I did that, that would be interesting. I'd have 5 equal parts. So I'd have 5 purple parts, 5 yellow parts, and the number of flowers would be equal. If I took away 4 yellow ones and 2 purple ones, I'd have 3 yellow ones left, 4 purple ones. Okay. But I don't really know how many to remove. The ratio of purple to yellow flowers in the vase is now 3-1. Okay, so I'm expecting a new ratio once I've taken some away. So it looks as if I've got to do some sort of trial and error as to how many are removed. And what I actually see is that if I take away 3 purple ones, twice as many, 6 yellow ones, I end up with a ratio of purple to yellow flowers. So always work in pencil with questions like this because you're not quite sure. There was a lot of trial and error going on there to see how we finish. Now, there are 14 more purple flowers than yellow flowers left in the vase. Okay, well, it's a double-headed arrow, okay, to show us that that difference is 14. Well, that's good. Let's see how the maths follows on from that. And how many flowers were in the vase at the start? Crikey, we're going to have to go back to our picture at the start to answer that. Okay, that's great. So we can immediately see that each of these parts is 7. How many purple parts were there at the beginning? There were 6 purple parts at the beginning. Oh, it's not how many purple flowers, it's how many flowers in total. Okay, so it was how many purple and yellow flowers all together, 6, 7, 13 parts. And that's our question done. Okay, that's the end of our video solutions for today. I hope you're enjoying your bar modeling. If you still don't understand any of those problems or have some questions, then please email your teacher.